Hey guys, today we're going to be focusing on exponential functions. The first type of function we want to look at is the equation of exponentials. So when we look at this equation, we notice it has an x and a y, or an input and an output. In this case, the x, or the variable, is in the exponent. That's what makes it exponential. Unlike linear or absolute value that had bars or no exponents, exponential has a variable in the exponent. That's how I kind of remember it. Now when we look at the graph, there's a couple things we notice about the graph. It always has a somewhat flat looking part. It's not actually flat, but it appears to be flat. But this one is always increasing. Exponentials will always increase or always decrease, but they'll never do both. And they always have a part that looks flat, but really it's just growing very, very little. Now when we look at the tables, the first thing we want to do is look at the rate of change. Can we cheat to find the rate of change? To cheat, we have to look at the x's. Here, my x's are going up 1, and so on. So that means we can cheat. And by cheating, it means we can look at the first differences. The first differences. Difference meaning subtraction. We're looking at how do these two things differ. What's their difference? The difference here is that I'm increasing by increasing 0.25. And then over here, I'm increasing by 0.5. And then here, I'm increasing by 0.1, or by 1. And here I'm increasing by 2. Notice there isn't a constant rate of change. The differences are all different, so it can't be linear. That's what makes the graph curved, is that the rates of change are different. But we always look for patterns in the first differences. In this case, there's a pattern to this sequence of numbers. I'm not adding the same each time. Here I added 1, here I added a half, but what I am doing is I'm multiplying by 2. 0.25, so 25 cents times 2 is 50 cents. 50 cents times 2 is $1. $1 times 2 is $2. That's the pattern. If you see the differences being multiplied or divided, that's what makes it exponential. Okay, you're looking for the differences that are not constant, but they have a pattern of multiplying or dividing. So when we talk about describing the rate of change, or an exponential function, we're looking at the following characteristics. This particular one, the rate of change is not constant. I know that because it's curved. It's increasing the whole time. And we can say the rate of change is being multiplied by 2. Alright, here's our second example. We have an equation here and we look for the input, or the x. Where is the variable? The variable is in the exponent, therefore it's exponential. We look at the graph. It's always decreasing this time. Always decreasing. And then you notice the flat part. It's not actually flat, it just looks flat. When we look at the tables, again, can I cheat? Plus 1, plus 1, plus 1, plus 1. Yes, I can cheat. So I come over here and I find the first differences. Okay, from here to here, ooh, I went down 100. From here to here, I went down 20. From here to here, I went down 4. 3 to negative 1, that's a subtracting 4. Here, I subtracted 0.8. Now again, if you're not good at doing that in your head, it's pretty easy. It's a difference, it's a subtraction. It's always y2 minus y1. That's how you find your differences. 23 minus 123 is negative 100. 3 minus 20 is negative 20. So you don't have to be able to do it in your head. You can use this formula. But I notice again, my first differences are changing. It's not constant. It doesn't have a constant rate of change. But there's a pattern here. Here, I divided by 5. here I divided by 5. And if I try to my calculator, if I do -4 divided by 5 again, it will be 0.8. So because the first differences are dividing, this is still exponential. So exponentials can multiply or divide. If we look at our little discussion here, this is decreasing, not a constant rate of change because it's curved. And the rate of change is being multiplied by 1/5. That's another way of saying it, multiplied by 1/5 or divided by 5. Alright, now we're looking at some graphs. Remember, exponentials have to either always increase or always decrease. This guy is always increasing, but he's got a constant rate of change. He's sloped, so he's not exponential, he's linear. This guy's interesting. He decreases here and he decreases here, but it's got 2 parts. Exponentials do not have 2 parts. So we call him an other. Okay, you'll study him in algebra 2. This guy, he's decreasing the whole time. He's got that little flat part that we've been talking about. It's not actually flat, just looks flat. And he's not straight, so he doesn't have a constant rate of change. This is exponential. Over here, see the flat part in the beginning? Not actually flat, but looks flat. He's always increasing and he's not straight. Therefore, this is exponential. This guy, he's kind of weird. He's increasing and he's decreasing at the same time. He's definitely none of what we've been talking about. This guy decreases and then he starts to increase. So he's definitely not an exponential. He has a different name. We'll talk about that later as well. So we've got 2 exponentials. The one up here and the one down here. Alright, after looking at some of these graphs and identifying which ones are exponentials, let's see if we can identify what tables are exponential. Again, check to see if we can cheat. +1, +1, +1, +1. That means we can just study our first differences. I don't know what that is in my head. Maybe you need some help too. I told you that to figure out the first difference, it's y2 minus y1. So I'm going to do 27 minus 81. Okay, you do that in your calculator. Okay, and you grab your calculator. Probably looks like this. And you just type it in. You don't have to be good at mental math to do this. -54 minus 54. I decreased. Over here, again, you can subtract. Maybe you're getting a little bit better at in your head, but that's -18. This is -6, -2. It's not a constant rate of change. So it could be exponential. It's always decreasing, but we have to look at the pattern. Maybe you don't know that pattern, but this pattern is dividing by 3. This is dividing by 3, so I check in my calculator. -54 divided by 3, that is -18. So because I am dividing, the first difference is dividing, that means it is exponential. Let's look at another table. Again, check our x values. Can I cheat? +1, +1, +1, +1. I can cheat, so I can study my first differences. This is a -3, -1. What happens here? Add 1, add 3. It's interesting. The rate of change is not constant, but the pattern is not multiplying. If I look here, this is dividing by 3. Is this dividing by 3? No, it's not. So it can't be exponential because I'm not dividing by the same thing every time. Another way to look at it is this is increasing, decreasing in the beginning, then increasing in the end. So it's not exponential. It's not exponential because it decreases and increases. Okay, so there's a little clue there that we went from negative to positive. Last one. Let's see if we can cheat once again. I've got plus 1, plus 1, plus 1, plus 1. That's awesome. So that means I can focus on my first differences again. I don't have to worry about doing the full rate of change or anything like that. So that's good. So let me get my pen here. So from first differences, here, that's an adding 2. I actually being bigger. Here I'm adding 2. Here I'm adding 2. Here I'm adding 2. What kind of rate of change is that? That's constant. So because it's a constant rate of change, it's not exponential. As a matter of fact, this one is linear. Okay, now maybe you need to go back and watch the video again and check some of your notes and fill in some of the gaps, but hopefully you know the key ideas about an exponential function.